We were starting on chapter 3 last class. Oh, I didn't open up. Okay. We had done, which we had already covered, but we did a few quadratic formulas and factoring. We also did square root method, but I want to go over one or two. I guess we'll do all three, but we're going to use it in completing the square. But when you're using the square root method, what you have to remember is when you take the square root of both sides, it leaves a positive and negative value. So if x squared equals a number b squared, when you take the square root of both sides, it's the square root positive and negative. So that x equals a positive and negative b. So if we look at the first one, x squared minus 9 equals 0. If you're going to solve by the square root method, there can only be the squared term. There cannot be an x term. And you want to get the squared term by itself. So we would need to move the 9 to the other side. How can we move that minus 9 to the other side? Anyone? Since we're subtracting it, add it to the other side so that x squared equals 9. Then we can take the square root of both sides so that x equals a positive and negative. The square root of 9 is 3. The other one, we have to move the 25 to the other side by adding it. But you still need the squared part by itself. How do we get rid of the 5? Anyone? Since you're multiplying, divide it. And then we take the square root of both sides. So x equals plus or minus. 5 doesn't have a perfect square root, so it stays under the radical. So plus or minus the square root of 5. Any questions? Okay, let's try the last one. X plus, oops, x minus 5 squared equals 9. Okay, sorry, my phone was going off like crazy. I thought maybe some people couldn't get into the class or something. So we take the square root. This whole thing is being squared, so we don't have to move the 5, because if we were going to move the 5, we'd have to square this first by foiling it. But since this is all squared, we can take the square root first. It still leaves a positive and negative over here. And the square root of this would just be x minus 5 equal to a plus or minus square root of 9 is 3. But then it breaks it into both parts because you have the positive 3. So x minus 5 equals the positive 3. Or x minus 5 equals the negative 3. add the 5 and get 8. Or when we add the 5 on this side, we get 2. So there's 2 possibilities, 8 and 2. Any questions on that? Now, it's always a good idea to check your answers. Taking the square root of both sides, they'll both work. If we square both sides, you have to check answers, but square root, they will both work. Any questions on that? We're going to use this process with the next one we're going to learn. It's up to you. When you have just a quantity squared and you don't have another x term, use the square root method. If it's factorable, factor it. The one thing we do know is quadratic formula works for all of them. So if you only want one go-to, it's the quadratic formula because it always works. But which one you use is up to you. So if you don't like the square root method, then use one of the other two. If it's not factorable, then you go to the quadratic formula. What's nice is when it's in this last one's form, it's easier to solve than you would have to FOIL this, get it set equal to 0 to use one of these, because remember, it has to be set equal to 0. So this one, we would have to take x minus 5 times x minus 5. FOIL that, subtract the 9 over before we can even start solving the problem. So when it's in this form, square root method is the easiest. But getting it into that, I don't know if you'll like it. And that's called completing the square. Depending on what classes you're going into, if we have to graph circles, not parabolas, yeah, parabolas, ellipses, hyperbolas, you need to be able to complete the square. For most of what we'll be doing, you don't have to use. So when we're completing the square, the first thing you want to do is get the x terms by itself. So get the x terms on one side. So I'm going to add the 9 to the other side, but leave a space. So we have x squared minus 4x, leave a space, equals 9. And whatever we do to this side, we will do to this side to keep our equation balanced. So you want the x terms on one side, the constant on the other. Now the next thing we do is we take the middle term and divide by 2. So we're taking this 4, we divide it by 2. Negative 4 divided by 2 is a negative 2 squared. Now I always write this value here because when you go to factor, it's going to be that value. So you take your middle term, divide it by 2, and then square it. Negative 2 squared is a positive 4. this side will factor into x minus 2 squared. So x minus 2 squared. And that's equal to 9 plus 4, which is 13. Then you can do like we did the last problem, take the square root of both sides. Don't forget the plus and minus. $13 doesn't have a perfect square, so it stays. I bring my 2 over. And that's your answer. Now, sometimes MyLabs wants you to write both answers and separate by a comma. So they just want you to do 2 plus the square root of 13, comma 2 minus the square root of 13. I'm fine with either way. Let's try the second one. So we have x squared minus 6x plus 1 equals 0. First thing we need to do, get the x's on one side, the constant on the other. So we have x squared minus 6x, leave a space, equals -1, and then we're going to add. So go ahead and find the value that we're going to add to both sides. Remember, it's b divided by 2 quantity squared. -6 divided by 2, you get -3. And then -3 squared is a +9. So we added 9 to both sides. When you go to factor, by leaving it like this, you already know what the factor is. If you would have put a +9, then you have to think about it more. So it's x minus 3 squared equals 8. Any questions on that part? It's always divided by 2. So completing the square isn't bad, as long as this number is even so that it's divisible by 2. If it's not even, then you have fractions to work with, which the next one will deal with fractions. Take the square root of both sides. Remember, plus or minus. So if x minus 3 equals plus or minus the square root of 8. Now, the square root of 8 has a perfect square in it, so we have to simplify that. So according to the formula, though, it will always be divided by 2. So we have this, we want to add the 3 to the other side. Now 8, as I said, has a perfect square in it because it's 4 times 2. Now, if you can go right from here to the final answer, that's fine. But 8 is 4 times 2, and we know the square root of 4 is 2. So it's 3 plus or minus 2 radical 2. Any questions on that? Okay, let's try a fraction. X squared minus 3x plus 2 equals 0. We have the x's on one side, move the constant to the other. X squared minus 3x, put a space, equals a -2 and another space, because we're going to add it to both sides. No, I wouldn't do the decimal. I've never tried. I don't know how that would work out. I always keep the fraction. So it's -3/2 squared. I guess, I don't know. I always keep the fraction. So then squaring, we'd have a +9/4. Oh, this -2, yeah, so we subtracted it to the other side. I usually use an arrow, but you could put -2, -2. So this drops out and leaves the -2. So then we divided this in 2, got -3/2 squared, which 3 times 3 is 9, 2 times 2 is 4, so it gives us a +9/4. On this side then, completing the square, x minus 3/2 squared. Remember, when you're combining these, if you want, you can place this over 1 and get a common denominator. Multiplying top and bottom, we'd have -8/4 plus 9/4. So combining these, I made a common denominator. Then I can combine -8 and 9 as 1/4. Take the square root of both sides. X minus 3/2 equals a positive and a negative. Square root of 1 is 1, square root of 4 is 2. So we have x minus 3/2 equals a half, or x minus 3/2 equals a -1/2. Add the 3/2 over. Three halves and 1 is 4/2, which is 2. Add the 3/2 here. A -1/2 and 3/2 is 2/2, which is 1. So we have two answers, 1 and 2. Any questions on the square root method? For the story problems that are in this section, revenue is price times quantity, because you think about it, revenue is the price you're selling them for times how many you sold. If I'm selling t-shirts for $5 each and I'm sold 10 of them, I made $50 in revenue, not profit, but revenue. So revenue is price times quantity. Quantity is usually X or Q. So it's whatever you're selling them for times X or whatever your variable is. X, it's usually only X or Q. Profit is revenue minus cost, because revenue is the amount of money you brought in, but you have to subtract what it costs to sell all those items, to build all those items, depending on how, if it's being manufactured through a machine, that would be in there also. So it's your revenue minus your cost. Looked a little blurry. I wanted to clear it. Now, equilibrium we had on the last test. Equilibrium is the quantity and the price when supply is equal to demand. So if you're finding the equilibrium quantity and price, you're setting supply and demand equal. You want to be careful. I didn't take off on the exam, but when you write it as a point, Q goes first, quantity and then price. But as long as you found both of them, they were correct. I didn't take off if you wrote the point wrong. But my math lab definitely wouldn't take that. So if they want it written as a point. In the next section, if you want to put the formula here, you could, but this is for 3.3. When you're doing Desmos and you're graphing piecewise functions, you use the script parentheses and you put the inequality here, and you'll see when we do them, but then it's colon in the equation. Piecewise functions, so you know what we're talking about, looks like these. Okay, let's try the story problems in this section. Number 5. The total revenue for a home theater system is R of X equal to 266X, and the cost is 2,000 plus 46X plus 2X squared. Each are in dollars. And X is the number of units produced and sold. So when I read an equation, I would highlight those things or circle them, so then I don't need to keep going back and look for them in a problem. Or I'd write them out. It depends. We want to find the profit function. Remember, profit is revenue minus cost. So I take my revenue equation and I subtract my cost. Now, the biggest mistake that I find is you write it like I just did. But notice I'm only subtracting the 2,000, not my whole cost. So you have to put a little spaces. Subtract the whole quantity. This minus is going to change all of the signs with my cost function. So we would make this a positive and then change all our signs. So 260, oh wait, X squared. I'll put the X squared first. I'm going to put them in order So -2x squared. And then 266 minus 46 is a positive 220x. Nicolina, can you grab my phone? In the big pocket. Minus the 2000. So I combined like terms. Any questions on that part? So this is our profit function. Any questions on finding it? You just take your revenue minus your cost. There's definitely one on the next exam, the in-class like this. What is the profit when 55 items are sold? Well, if we want to know the profit when 55 items are sold, we need to decide if 55 goes in for X or for profit. We'll think about the terms and what each is. 55 is the number of units or the systems. What is profit? We're looking for profit. So we're plugging 55 in for X. So we plugged the 55 in for X because we wanted to know what the profit is. And then we just plug that in. You're getting 4,050. If we produce and sell 55 units, we will make $4,050 profit. Any questions on that? Again, from your last test, break-even quantity is two ways. You could either set revenue equal to cost or profit equal to 0. Since you've already combined revenue and costs, it's easier to set profit equal to 0. But if you didn't find profit, then you could just set revenue equal to cost. So break-even quantity, we're going to let our profit equal 0. And our profit was the -2x squared plus 220x minus 2,000, which equals. So we're setting our profit equal to 0. Any questions on that? No, you can solve that any one of the ways we just did. You could do quadratic formula. You could factor if it's factorable. You can do the square root method by completing the square. Whatever way you're comfortable with. But if you're only going to pick one, you need to pick quadratic formula because it works all the time. So to get the profit function, I knew profit was revenue minus cost. So I wrote the revenue and then minus, and this whole thing was the cost function. Then I made this a plus and distributed my negative. Rather than having to rewrite it, I just made this a plus and changed my signs. Then combine like terms. I put my squared term first, so negative 2x squared. 266x minus 46x gave me the 220. And then my minus 2000. And then that's what I used here. If I was gonna solve this, the first thing I would do, I know it's x squared, so I either need to do one of the ones we just talked about. But notice that all of my terms, how many terms are here? In this equation, how many terms are there? Anyone? 3, okay. There's 3 terms on this side and then 1 on this side. And all of them are divisible by my leading term. It's a lot easier to factor if this is 1x squared. So I can divide all of them. Now, if it's not divisible like evenly, then I wouldn't divide because you don't want to work with fractions. But since -2 goes into all 3 terms on this side and 1 on this side, so all 4 terms, make your numbers smaller. Now we have a positive x squared. Here we're going to have a negative 220 divided by 2 is 110. And negative, this becomes a positive 1000. Now you can factor it or quadratic formula. Does anyone have a preference? Would you try and factor this or would you use the quadratic formula? Factor, okay. So to factor it now, we don't have a number in front, but we need 2 numbers. When we multiply, we get a positive 1000. And when we add, we get a negative 110. Okay, we'll do both. So negative 110. This is negative, so this would both be negative, so that we get the positive. If we took a negative, negative 10 times a negative 100, we will get a positive 1000. And when we add those, we'll get a negative 110. So multiply to get this term, add to get the middle. That means it's x minus 10 and x minus 100. But it's not necessarily the easiest thing to see. Set them both equal to 0. And we're getting 10 and we're getting 100. Now, what happens if we look at revenue? It's a straight line because it's x to the first. And my cost is a parabola. So it looks like this. And what's happening is we have this intersection at 10 and this one at 100. Here, is where we're making money, because the revenue is above the cost. So 10 is our minimum break even quantity. Did this one ask for minimum? Oops, I'm looking for wrong part. No, just said break even quantity. Most of the time we'll ask for minimum. The minimum break even quantity would be 10. This is where you start making money. So this is where you start making money. But then when you hit this 100 mark, notice cost is way above it. This is where you start losing money. So if they're looking for a minimum break even quantity, that's the smaller of the two values. That's where you start making money. That's where you just broke even. This one is the one where you need the new version to come out. So if this is an iPhone 5 we were talking about, once we get to 100 units, whatever that is, whatever the units are, it could be thousands. Once we get to that point though, we need the new one. And so they use projections like this to see how much time they have before they need a new one to come out, because this one's going to start losing money. They're not going to produce it anymore. I'll do the quadratic.
On a graph, so on a graph, the like where you are earning a profit on like a cost revenue graph would be below the x-axis.
Probably not. I mean,
But
part of it might go below, but when we're talking revenue and cost, usually they would all be like, if I drew the axis, it would be like that.
because like with okay, because it's kind of confusing, because is it not, are you not finding the solutions to the graph?
You're seeing where the two intersect.
Okay.
Axis wise, for a business problem, it should all be in the first quadrant.
Okay.
So it shouldn't hit the X, and it might hit the Y axis, but then part of that would just be thrown out. But it should, I guess costs could go in the negative. You could have a negative cost till you start making money. If we look at those two equations, the revenue was 266. And the other was 2000 plus 46x and 2x squared. 2x squared. Now, of course, it's not showing because of my units. So I'm going to go the other way. I'm going to make this -1. And this one x 150. Oops. Um, Geez, it's not. There we go. Did I type something wrong? 2000x plus 46x. Okay, usually the graph will all be in the first quadrant, but this one is not, but where it hits 10 and 100, it is. But here at the 10 and the 100, because these numbers were so big, it's not showing as nice as I thought it would. But normally it will go through this way more. I'm gonna keep this open though. We're gonna need it. No, there we go. No, come on. But normally you'll be able to see it better. This one, it went here. But the lower value is where you start making money and the higher value is where you start losing money. And someone had a question about doing this with the quadratic formula, so I'll show you that. Now, I still would have got rid of the -2 because my numbers are smaller. A is 1, B is a -110, and C is 1,000. Quadratic formula is this. So it's a negative B, so negative times -110, plus or minus the square root, -110 squared, minus 4 times A times C. All over 2 times A. First thing we do is calculate the discriminant. (110 squared) minus 4 times 1 times 1,000. Negative and negative's a positive. Plus or minus the square root of 8,100 over 2. Square root of 8,100 is 90. So we have 110 plus 90 over 2 and 110 minus 90 over 2. When we add, we get 200 divided by 2 is 100. Subtracting, we get 20 divided by 2, which is 10. So either way, you're going to get the same answer. These numbers get a little large, but you have a calculator. This always works. Trying to find the -10 and the -100 to get the 1,000. That might take a little more time than just plugging into the quadratic formula. But either way will get you the same answer. Any questions on that? The last one. The demand for diamond stud watches is given by P equals 7,000 minus 2x, and the supply is P equals 0.01 x squared plus 2x plus 1,000, where x is the number of watches. And price per watch is in dollars. We want to find the equilibrium quantity and price, so we need to find X and P. Equilibrium is when the supply and the demand are equal, so we would set them equal to each other. 7,000 minus 2x equals 0.01 x squared plus 2x plus 1,000. Now you can bring them to either side. Since my x squared is positive, I would probably leave it here and add these two to the other side. Because I have an x squared, it's quadratic, you have to get it set equal to 0 before you solve. So I'm going to add the 2x. And I'm going to subtract the 7,000. That will leave 0 on this side equal to 0.01 x squared plus 4x minus 6,000. Any questions on that? Again, I could divide by this, all 4 terms, but my numbers are going to get big. 0, x squared, 4 divided by 0.01 is 400 minus 6. One, 2, 3, 4, 5. Now you could solve it by factoring. But I think quadratic formula would be easier. Any questions on it? How did you get those numbers? Oh, from the problem. 7,000 minus 2x. And 0.01 x squared plus 2x plus 1,000. Since they were both set equal to P, I set them equal to each other. So I use substitution. These. Okay. What I did was got rid of this. Probably should have put that stuff. I wanted to get the x squared, so it was just a 1, so I divided everything by 0.01. So we have 0, 1x squared, 400x, and 5 zeros. You're welcome. I would use quadratic formula. Negative 400 plus or minus the square root 400 squared minus 4 times a times. Make sure you take your sign with your values. All over 2 times a. 400 squared 4 times. Oh, I didn't. There's one more zero. Okay. All over 2. And take the square root of that. And you get 1600. So it's a negative 400 plus 1600 over 2. A negative 400 minus 1600 over 2. This one gives us 600. This one's going to give you a negative value, negative 1000. Which doesn't make sense because you wouldn't have a negative 1000 units, or in this case, watches. So it would be 600 watches. To find the price, you just plug it into either one of the equations. So we would sell the watches for $5,800. And you can use either one of the equations, supply or demand, you will get the same answer. Any questions on that? Okay.